comment about the UV loop or event loop. Can you elaborate the question here?
Yes. So I guess we use the UV loop for the gRPC server itself. So the gRPC server uses the UV loop as an event loop, and that's how that's what it is based on.
Yes.
Now I'm working on building the API around it, the REST API around it. So that also uses a similar kind of either an async IO loop or the UV loop that comes by default. Now, when Jina closes the loop, that closes the loop. I mean, that closes the loop for the UV loop on top of the REST API as well. So I'm not sure how do we handle these cases. I'll dig deeper, but if you have any suggestions, please let me know.
But my question is why is this UV loop like lives in the same process as Jina? Shouldn't not the UV loop? Why is the event loop of fast API let's say lives in the same process as Jina? I thought it's completely separated, right?
Yes, I think then we need to trigger everything in Jina in a separate process. Then only it will be. I mean, yeah, that's one way to take care of it. Yeah.
No, I was thinking like so basically if you look at the daemon process that we were talking about, right? And so this daemon process basically start a separate process that basically receive REST API, provides REST interface, and also spawn, stop the flow and part MP. And why is this somehow like? So how do you want to spawn the flow? You want to use like you want to do this inside Python, or do you want to use like the command line interface to do that?
So currently, since Fast API is based on Python, I'm working on the main thread itself. On the main thread itself, I'm starting the Jina flow. So that's why it is residing in the same main thread, and that's why this event loops might be coinciding.
Okay.
But yeah, my plan was to basically convert the same Python script, Fast API command to a systemd profile later on, so that we can invoke the Python function itself in the systemd.
No, so what I mean is, so basically, let's say you have this guy, let's say a spawn flow, right? So let's say it's bounded to some, let's create a new one. So let's say we have this spawn flow, and then you bound it to some certain, for example, get some interface, right? Something like that, right? And then you're saying that, so we basically start the flow inside this, right? Start a Python flow inside this.
Yes, as a context manager, yeah. But I mean, you mean to say starting from a CLI command itself will be better?
Yes, yes.
Okay.
Because I would imagine, because if you start flow like this, then this process just gets blocked, right? So you cannot start another flow using this gateway anymore. Or using this daemon.
Yeah, I was planning to start another process inside this, which will be the blocking flow instead of using the flow.block itself. I was planning to do that. The reason this would help is just starting from CLI would not be, it would not be able to respond the right kind of parameters. Like if I want to send the number of P's and number of pods to the API as a API response, from the CLI it will be difficult to do. So that's why I was planning to do it as a Python object itself.
So basically, no. I still suggest that we do this using CLI for two reasons. So one is that if we do this in CLI, right, then everything that happens inside the console is basically a sub-process. So it's completely different. It's separate from the main process. It's kind of like a protection of the main process. Otherwise, so if you start something like this, right, so basically you call f.start. Then the flow is actually living in the main process, right? And basically, it's living in the same process as your fast API gateway lives, right? And if the flow is broken or through some exceptions, then the gateway is broken. You cannot use it anymore. But if you do this,
okay.
let's say you start with, for example, subprocess dot, I don't know, I think it's called, right? And then saying Jina flow, and then uses some my flow dot YAML, right? If you do something like that, right, then if this subprocess dies, then it dies, it dead, right? So there is no, it doesn't affect the main process.
Right. So that seems like a better way. But if you want to build a response around it, about how many, I mean, all the flow parameters that a flow object gets in Python, how do we send that? That will be limited, right?
Yes, but then I would suggest to
So my plan was to not start the flow in the main process itself, start another process, and I mean, start a multiprocessing thread, multiprocessing or a thread where the flow will lie, and we can set an event where we'll kill that, or if that gets killed, also that does not hamper the main process.
Yeah. Okay, all right. Okay. Yeah, so I think it's not really a problem, but you can try, because I think I remember I did some optimization on the event loop creation and the destroy. So basically to make sure that if you start with multiple process, then this event loop won't conflict with each other. Yes, but I don't remember the details, but you can try on you can give it a try of this. Yeah.
Sure. Yeah, I'll keep you updated. Yeah, thank you.
Yeah. All right. So just to be sure, just to make sure that everyone on the same page. So basically, we have this daemon feature that that allows the remote control of Jina. Right. So basically, you can just say you can write the flow like this, and then so basically it will kick off. It will spawn a pod on this machine. Right. So the process is as following. So let's say you have a local machine, and then you have a remote machine, and this remote machine is running this daemon, right? And you say, okay, f.build, and then basically it found out that, okay, so you have a pod which requires to be running on this host. On this is not a local host, this is a remote host. And then it basically called the HTTP interface, basically called the HTTP request, and send the arguments and also the YAML file, right, to the remote. Right. Notice that, so this basically you need to send all the information, all the context to the remote, not only the arguments, right? If the remote server, only on the remote server, you don't have the uses, and also include inside the uses, inside the YAML file. If you just, let's say, if you use Python modules, you cite external files. So those requirements has to be also satisfied on the remote side. But right now, let's make it simple, right? So let's just send the arguments and also the YAML file to the remote. And then the remote receives this, this kind of request. So this is basically what the REST API does on the remote side. And it listens to the HTTP request, and once it receives, it has three ways to start the pod, right? Right. So one way is basically to say, okay, so I just start a Python native pod using Jina pod uses, right? So basically, it's from the CLI, and the other way is using containerized image, right? It's also like Jina pod use. The third way is actually basically does not rely on Jina anymore. It's independent from Jina, so you can just say, okay, Docker run Jina. And with this uses all the arguments and so on. Right? So in this case, the remote machine they don't even to have Jina installed on the remote. So you only need to install Docker, right? And then this will basically run the spawn the pod. And once the pod is spawned, right? So you basically say, okay, so it's success, please check. And then we basically here we wait the pods to be ready. We do the health check, and once it's success, and we can run the flow or dry run the flow, right? And notice that so basically when we run the flow, right, all the data is basically off. So this has to be clarified, right? So when we run the flow, all the data request is actually sent by RPC level. So basically at 0MQ, using 0MQ, right? And but the HTTP request, what is the interface? What is the HTTP request for? So HTTP request is just for like monitoring the health status, logs, and so on, right? So gather all the status, for example, in JSON file, in JSON format, right? And so this is how it looks, right? So this is so basically the RPC is actually directly to the pod, right? But HTTP is actually to the daemon, right? And finally, so when you close it, and then basically just send the HTTP request to the gateway and let it close, right? So this is basically the idea of the one use cases. So the other use cases is basically you can also start a remote flow, for example, from the dashboard. And the idea is basically the same. You specify your YAML file, flow YAML file, and then you want this YAML file to be started at this remote machine, and then you send this all the information inside this YAML file, and also the arguments into remote. And so basically you will spawn the flow. But what is really interesting is that, so now if you look at this part, it actually becomes the use case one, where the remote machine found out that, okay, so you are actually you actually want to start another remote pod on another machine, right? So that is basically check. Okay, so now I'm going to delegate the pod onto another remote machine, right? So in the end, you can imagine this can be very powerful, especially for decentralized architecture. Right? So you can imagine in the future, let's say we have a set of machines which has a Jina daemon installed, right? So they basically becomes the usable instance where you can spawn all the pods and the flows however you want, right? And you don't have to you don't have to worry about this machine anymore. So those machines somehow becomes your slaves. You can just use it as in your Jina Flow API, right? And also from the dashboard, yeah.
I have one question, Han,
yeah.
regarding this. If we are sending requests directly to pods, aren't we losing the concept of flow as a context manager, taking care that everything is released properly and so on?
We're not sending the request directly. I mean, so are you talking about the data request or what?
No, I'm talking about like if a client can spawn a pod individually, the flow will not be able to track that pod. So it loses the concept of context manager for pods.
Yeah, but so right now you can already do that, right? So this is a feature that we already have, but right now it's using RPC, it's using gRPC to start this flow, to start the remote pod or remote.
So that is a question I had. There is no base P controlling. There is no pod connecting to the remote pod so that it closes when the flow is closed and so on. At this moment, we don't have it.
Right now we have it, right? So basically, when the remote pod is start, so we basically it exposes incoming point and outgoing port. So incoming port, outgoing port, and also a control port, right? And so those port along with the address, the IP address of the pod is known to the flow, right? So with all this information, you can send your data request to the pod from the flow, right? You can also shut down the pod from the flow because you know the control port.
Yeah, but you have to inform the flow that there is a new connect. I mean, adding a pod has effects on their neighbors. And this is handled by the flow.
Yes, because the flow, when the flow is built, it's already pre-computed, pre-populate all the port and address to make the to make everything work. And then so basically the pod doesn't have to take care, doesn't have to know what is neighbor's address.
Yeah.
Right, because it's already computed already, right? So we are already make sure that this network is the connectivity of the network by assigning the correct port, the correct address to the correct pod, and then each pod doesn't have to take doesn't have to to be self-aware on the network connectivity.
Okay, but it won't be able to add an extra pod in the middle of the process.
No.
Okay.
No. So currently this is not supported. Yeah. But you can, but what we can support is actually the auto scaling, right? So we can actually add arbitrary piece inside the pod.
Yeah.
Yeah, because yeah, I mean the inside the pod, so all the pieces are actually invisible to the outside. So I mean the changing their number doesn't affect the port, incoming and outgoing ports. Yeah. Yeah. So do we have more questions?
I had planned one question for like similar to this. I am curious because it is not so easy to see what is the process from when a flow asks for a pod to be added in a remote machine. What are the steps that happen inside? How we are connected? How does it send the YAML file describing the pods with this spawn request? This is a little bit unknown to me.
So one way is, so you can imagine, I mean, sending the arguments and also the YAML file. I think this part is relatively straightforward, right? So you just package them in a JSON file or use post, package them into binary format and then post it to the via the REST interface to the remote, right? And so once the remote receive this request, it will spawn the pod, right? But notice that on the local level, I already know the remote address. I also already know the port that they are going that this remote pod is going to use, right? So I can basically without asking the gateway, without asking the daemon again, I can just say I can just keep ping the pod until it's ready.
No, yeah, I am asking of the current status, not with the daemon.
Okay, so without that, so without the daemon, then we basically, so this is the current status, right? So basically, we use gRPC to do there is a spawn request, and then basically it's actually a long, let's say long, how to say this, long connection. Yes, it is a long connection. So basically, once you set up this long connection using the spawn request, it's basically build a log stream between the remote and local machine and local pod, right? So, but here I use some, I started, so inside the remote pod, so there is I equipped gRPC, a small gRPC client to send this kind of spawn arguments and also all the other things. So this is how we implement it right now. So we have this spawn request, and also we have a remote pod, which is basically a wrapper around a small gRPC client, right? And you can actually look at the protobuf here, right? So basically, this is the This is a spawn request. You send all the spawn information arguments into remote, and as the return is actually a stream, right? A stream of spawn requests. So this is actually used for streaming the logs from remote to local. Yeah.
Okay.
Yes. Okay. So do we have more questions? I have a small presentation regarding the code formatting today. Yeah, Max.
Yes.
Please.
I can do that. So
let me share. Let me grant the share screen things.
Yes.
Yeah. Okay.
So I guess you can see it now. So
yeah, we see.
Yeah. So what I want to do is I want to showcase Black for a moment, show what how it would perform on the Jina code base, and afterwards somehow have some personal arguments if why use it, why not use it. So first, to introduce Black, I took from their page somehow what it is. So it's an uncompromising Python code formatter. It somehow, when you use it, you somehow have no control anymore about the code formatting, and especially there is no need for hand formatting anymore because Black will always, in a deterministic way, very fast change your code style somehow to the default Black code style, and so you never have to care about your code anymore. And the nice thing is, whenever you use this, the code looks the same regardless of the project, and after a while, when you do this, so I have experiences in my past where I use this, that you somehow get the view for how certain code blocks look like and what happens here and there. So that, at least for me, was a really nice experience. And it also makes code reviews faster. Why you will, the smallest diffs, you will see in a second why this is true. Yeah. And so that's the general idea of Black. So it's a code formatter, which you almost can't configure. Now I want to showcase some examples, some files, what would happen. So this is just a git diff on some files in Jina. I just took some to demonstrate it and no somewhat dedicated use. Here you see the imports, especially the one that go where the lines get very long. They're somehow breaking down. So Black by default has a line length of 88 characters. And when it gets longer, it breaks them down. And here's the nice thing of this kind of writing the imports is when you change them, it's just somehow when I add now in the here would add another thing that is imported from accepts, I would just see one diff in Git, which is pretty nice because then you directly see, okay, this is the change. This is somewhat the very same thing, got too long. This one is putting the bracket, which was here, somehow just at the lower on the next line, which somehow closes the bracket at the same level of indentation as it was opened somehow. Yeah, what would happen here? This line is too long, so it puts all the parameters on one line, and then close the brackets again at the same indentation, and then have also the return value back here. This is somehow when you have such a long line, you want to see the somehow type of the return value, you have to go to the back. The nice thing here is you somehow, when you get used to reading function definitions like this, you know, okay, either it's in the back when it's a short line, or if it somehow gets longer and needs to be broken, you always have it on the same indentation level as the definition. Somehow there is then the return value. What happens here? Here again, just a bracket that goes on the next line. Here's somehow this if is broken down. The second end also on the next line because the line itself got too long. And yeah, so that's the in our code base, somehow what I saw mostly is the lines are too long and I got broken down into multiple lines. This is also the rest in this file. I have one more file which I liked. Let me have a look. Yeah, here you see again what is here. Somehow the when you read this line itself, it's somehow hard to distinguish. Okay, where does the comment start? Okay, usually in your IDE it's a little bit colored, so it might be easier than just in the git diff. But again, you somehow see, okay, for this function, these are the parameters, and then the comment is somehow separated from them, so it's easier to distinguish these two things. And here as well, this got too long, so it's broken down into one line each, and which is better readable in my opinion. But I think code formatting is a lot of opinionated, but just to showcase, okay, what would happen with our code base. And most things will be line breakdowns because the line are longer than 88 characters. So my personal opinion is the Jina code is already pretty well formatted. So from this point of view, we wouldn't need the code formatter. But I rather see this as when we now get more and more contributors, where everybody has their tiny little code styles here and there, where they do things a little bit different. The code gets not as well formatted as it currently is. And the nice thing about having a code formatter is that somehow it's always the same, and you somehow have always the same format. Why I like Black is because you don't have this fights about, let's do it like this or like this, because it just has more or less one opinion and that's it. You can't change, configure it. And when you have a code formatter, once we have it, you never have to think about it. We could make it as a merge hook, and then even people can write really bad looking code before it's merged to master. It would always be reformatted, and then the master would always be master branch. When we do a squash and merge would always look nice, and also the commits would always look nice because we would do the code formatting before the squash. And for Jina specifics, one thing that we would need to do is Black usually use double quotes, but we can somehow disable this automatic back and forth formatting and just have the command skip string for normalizing. Then the quotes would just stay as they are. And the second thing where I like the 88 characters because it helps when you somehow split your screen into left and right. But I know there are sometimes people who like rather 120 or a longer one. So you can also increase the line length. That could be something where we think, okay, perhaps you make it a little bit bigger if we would use Black. Yeah, that would be up for discussion, but there is no more that you configure. So all other configuration of Black somehow are not useful for us. And there is more or less not the possibility. And this is for the reason that whenever you switch to other Python projects, somehow you always have the same formatting. Yeah, and Black is, as far as I know, more and more used in the community. And that's why I want to present it and somehow got the discussion rolling if we want to use it. The first commits where we use it will change a lot of lines of code, because I think it's best when you start with something like this, just let it roll once through the whole code base, and then it's uniquely formatted, and then you can keep going with it. Yeah, so I would like to introduce it, and now please add your opinions.
I think it's a good idea. Could we have an initial commit where we apply to everything and build up from there, so that we have a big commit with all the formatting, and from there it is business as usual?
Yeah, that might be a good idea. That I somehow, and then you can also look at it and see if there are things that really bothers you. Somewhere where you see, okay, no, that doesn't work for me at all, or things. Yeah, that might be a good idea.
I personally like the idea that it kills the conversation.
Okay, cool. And so do we have like more question about the code format and some kind of like a meta works that we have right now in Jina repository and so on? Okay, then if we don't, then we have actually have community questions right now, right? And we have a community member, Beta Yuan, and she asked, I would like to use Jina as my retriever for a passage re-ranking task, specifically to first reduce my document pool size to the top K candidates, and then fine-tune the candidates' results on pre-trained language model to re-rank them. So I understand that the current Jina framework doesn't allow one to train custom models. So I would like to know what is the easiest way to introduce this intermediate re-ranking step if I want to use Jina again at inference to get my final search result. Yeah, so Anyone want to answer this question?
I am not sure I understood it correctly, but for me, what you bit here, I hope I pronounce it well, are asking is whether we support the re-ranking phase in any search system, and we do. And we can look at the family of rankers and the ranker drivers, and we have the ability to re-rank with any scoring function that we wish that might need to be developed for your custom need. But we definitely have this feature.
Hi, Joan. Thank you for the answer. My question is more because as a re-ranker, you could also fine tune a pre-trained BERT model to re-rank your results. So what you will actually do is, like there's a paper, it's called Passage Re-ranking with BERTs. And what usually you would do is use like a Lucene toolkit that uses like BM25 to first retrieve a top 100 results. And then you would use these results and then fine tune a pre-trained BERT model. So then, and then to re-rank them. So it's not using like the normal scoring, but using like you have to fine tune like your pre-trained BERT model. And like I was wondering, because now the Jina framework doesn't allow for like fine tuning or training a custom model. And if I would like to do this, then I have to use, I would have to index my data and then get my top K results. And then I will have to export these results and then fine tune my model. And then if I want to use Jina again at inference, to get my final search results, I would have to like re-index again using this custom model that I pre-trained. So like, I was wondering if like, this is what I have in mind, but I'm not sure if there's an easier like way to do this.
So just as a question, what you expect is to fine tune your model while you are searching.
Yeah,
so even in your live example, in your live search.
Well, I was thinking that I would have my live search first, and then I wouldn't like, not live searching. I think it's more before I search, I would like to first search and then pre-train, and then like my final search would then be based on this model that I pre-trained. Does that make sense?
And would you then in your final search somehow use both models? First the BERT or the whatever model you first used for retrieval, the top 100 or whatever, and then also the pre-trained model, and both together, or do you just want to use the pre-trained model afterwards?
Just the second one.
But then you can somehow, as I understand it, you can write a new flow where you use your new pre-trained model, and yes, you have to index your whole data somehow once again with your pre-trained model.
Mm-hmm.
But afterwards, once it's indexed, then you somehow can use your pre-trained model.
And then I can specify that I just want to use this new model, not the old one.
Yes.
Oh, okay. So this is possible. Like I could do this.
Yes, I think yes. You somehow I think even you can just use the same Jina data, somehow the same flow for both, and just change your old model with the new model.
Okay. Okay.
From my understanding, that should work out of the box.
Okay. Thank you.
But this is a very interesting use case, and we would like to know more about this. So if we can, like, I'm not sure if you are in our Slack channel. So you can just send us some message about all the, like, what do you want to evaluate and how the training data and the evaluation data looks like. That would be perfect. Because right now we are building the evaluation flow and also the training flow. And you can expect those, let's say, features to be rolled out, let's say, in the upcoming months. And so we really would like to see what is like the concrete use cases here, and this also help us to design this kind of search pattern or design pattern better, right? So really appreciate that.
Okay, yeah, thank you.
And yeah, Bithia, I sent you a link to our Slack, an invite, so feel free to join.
Thank you so much. Actually, I had another question. It's kind of related. So because this is a topic that I did for my master's thesis and I just finished it. It's very recent. And like for my master's thesis, I used like a Lucene toolkit called Answerini. And I think this is often used in academia for these passage re-ranking tasks. And for Answerini, it allows the user to load the index documents into the search application separately. And like one can even use this in like online notebooks like Google Colab. And I tried to like install Jina on Colab, but it didn't work. And then because like it was really easy for me when I was learning how to use Answerini to have this online notebook option. So I was wondering, like, are there any plans for Jina to introduce something similar?
Okay, so the thing is that the thing about the Google Colab is Google Colab using Python 3.6, right? And Jina is built on top of Python 3.7 and above. So right now we cannot support Python 3.6 because the asynchronous package in Python only becomes, let's say, graduate or mature after 3.6. So basically after starting from 3.7. So we can safely use asynchronous mechanism from 3.7. And also like asynchronous, this kind of thing is very, at a very low level of Jina. So it's actually a very, it's a core feature that we cannot compromise. And so for Google Colab, well, right now we cannot support that. But I mean, if there are other Jupyter notebooks that host it in other places but support 3.7, then of course we can use that. Oh, sorry, no, we can use that, but we can support that. Yeah.
Okay, thank you so much.
So I mean, I use Jupyter notebook from time to time just to do, for example, flow visualization and so on. And so we don't have problem with that. But this is because the backend of this Jupyter notebook, they're using 3.7. Yeah.
Thank you.
All right, so do we have more, like, I see there are more community like members join the Slack. Sorry, not join the Slack, join the Zoom. Do we have questions from them? Or maybe, so for those community members, feel free to introduce yourself to our, to Jina and tell us why are you interested in Jina and what are the particular use cases that you wish, like what is the top features in your vision list for Jina?
Come on, people, don't be shy. Otherwise, we'll start calling you out alphabetically. and you know your names. You know who's coming first alphabetically. So
yeah,
speak up before teacher calls on you.
Hi, everybody. My name is Bithia Yuan, and I just finished my master's in computer science from the University of Freiburg, and I just moved to Berlin. And I found out about Jina actually because of a job posting. And because for my master's, in my master's, I concentrated on natural language processing and information retrieval. So I've always been really interested in semantic search. And when I found out about Jina, it was really interesting because it was not just for textual data, but also for other modalities. So that really caught my attention. And I think the biggest feature that I would like to see is this, to be able to train your custom models and then use it, during inference, during search. I think that would be really interesting. And then another thing is that I wish that the tutorial, like the Jina 101, could have more concrete examples, because when I first read that, I was a bit confused about the pods and the flow and the piece. Yeah. So, and because I come from more of a machine learning background, so I'm not very, I don't have the expertise in service-oriented architecture. So that was a bit overwhelming for me at first. But now I'm learning and it's very interesting. Thank you.
Thanks, Bithia.
Yes, actually, yeah. So those two things that you have mentioned are actually on top of our, let's say, our internal roadmap or the feature list, right? So one is actually about the training flow, but this is actually not trivial. If you think about this, so the Jina is a very complicated system composed by a lot of components, and those components are fully decentralized. They are connected via the HTTP or RPC, this kind of thing, right? And each component can be tuned in different ways. Then how do you somehow optimize each component so that the global solution, so to reach some kind of like a global optimum for the overall system. So this is I would say this is a non-trivial question. It combines both research effort and also the engineering effort in order to build a good solution for that. And in regards of the examples and tutorials, yes. So the current version that we have online isn't perfect, especially on the onboarding, for the onboarding for the newbies to learn. This is not still put too much effort and too much stress on the newbies. So this is something that we really want to optimize. And so the thing is that, Jina, unlike other popular machine learning tools, which focus on one-liner, right? Basically provides a one-liner interface so that you can do your job in one line. Jina is a framework. So we call it a TensorFlow for search, right? So there is a learning curve there. This is for sure. And also there are some concept and also the philosophy design, which is a different, which could be very different, something new for machine learning engineers. So this is something that we really want to optimize in the future. Yeah.
Mm-hmm.
All right. Who's up next? Has someone run away so they don't have to speak? Speak to us, Alok.
Hi, I'm Alok. I did play around a bit with Jina at the hackathon, but I had a few issues with getting a few things to work. But very, very interested in the project as a whole, and I really love the idea. And I think just keen to keep up with it and try to see some potential use cases, specifically multimodal search with text, image, and video data. So that's what I look at.
Awesome. Thanks, Alok. It was good to have you at the hackathon.
Yeah, thanks. It was great. It was a great learning experience.
What projects are you working on at the moment?
Well, I think I would more say I'm still learning machine learning. So I'm from the most sort of traditional software engineering background. And I think over the lockdown and over the corona, I've had some time to actually get deeper into machine learning. So I would still say I'm still sort of at that learning stage. But I think it's all starting to make sense in terms of creating large sparse embedded vectors of various content and then using some sort of a search FICE or some sort of a search base. And I think it's really starting to sort of come together. But I would still say I'm still at the sort of learning stage at the moment. But specifically very interested in NLP. So before this, I tried learning some natural languages. And I think it maps really well to sort of some NLP kind of applications.
Well, this actually reminds me. So right now we don't support sparse embedding. We don't support sparse vector in the protobuf level, right? And so we have to look at this. We have to look at these sparse vectors because this is actually a very long-term feature, not long-term, long history features that I want to support like years ago. But somehow I just this slip out of my mind. Yeah. So what kind of like a sparse vectors, like are you using SciPy, this kind of sparse matrix, or what representation, what data representation are you using for representing sparse matrix or sparse vectors?
Nothing particular at the moment, but I've certainly looked at a lot of recommendation type algorithms and maybe even the anomaly detection. And it's more, is it potentially possible to use some sort of a search algorithm that goes across some of these use cases? But like I said, there's no specific use case at the moment. It's very much still at that sort of figuring out and learning. But I think getting sort of getting an understanding of project like Jina will aid towards cementing some of those ideas. So that's why I'm quite keen to follow it.
Yeah, but yeah, okay, good to know. But I think this could be a very feature with a high business value, and we should consider it in the next sprint or something.
Yeah. This totally makes sense because for the sparse vector, we actually have to switch to the other ANN method. For fast and annoy, they only support the dense vectors, and if we want to go to the sparse vector, we should go something like the spar-NN.
Yeah, because this I just can't believe it. I just forget this idea all time long. I mean, this is a very something that, yeah, it's very straightforward feature, but just somehow I just forget it. Okay. Cool. Thanks a lot. Yes, that's why we keep the community aside, because we always get inspiration from that. Thank you a lot. Yeah.
Who's up next? Hai Long, am I saying your name right? Hello. Nothing from Hai Long. Okay, well, we'll come back to you. Don't worry, we haven't forgotten. Xiao Lu?
Hey, hello.
Hey, good to have you here.
Hey, happy to meet you. And I'm very new to Jina. I have just know about the Jina projects about last week. And recently I'm working as a software engineer, and I have some interest in building some search application. So when I see the Jina projects, I feel very interesting, and I would like to build some picture or some wiki search features with Jina. So I'm still very new, and maybe I need more time to learn about the project.
Cool. So what primary language are you using? Program language are you using?
Yeah, generally I'm using Golang.
Oh, okay.
Yeah, basically on search backend.
Understand.
Yeah.
And yeah, so I guess on the Golang. So basically on the input, at least from the data ingest perspective. So I mean, when we are doing search, right? So basically, you need to feed the data into the system and then later look up from that, right? So basically, this involves a very basic step, which is basically input and output, or we call it the data ingest. And at least from that perspective, Jina is pretty universal. So it provides a gRPC interface. And you know, Golang is actually pretty native when we talk about gRPC, right? And but right now we don't have a Golang client that can communicate with Jina system. But we do have a REST API, so you can also use HTTP requests to communicate with Jina. But that's actually not I would say not. So when you do the indexing, that's not the most efficient way, right? Because it doesn't support batching, streaming, prefetching, this kind of advanced features, which is already implemented in the gRPC gateway. And yes, so this is also something that I previously want to implement it, or want to have this in the feature list, is basically support languages, support clients with different languages. And I think yesterday David also points out he wants to have Jina box as kind of hook, right? Implemented and then put into using Node.js or TypeScript or whatever, this JavaScript language. And I think it's strongly related. For major programming language besides Python, I think we at least need to support Go, Java, and JavaScript.
Yeah, maybe we can work on some Golang clients or some Golang interface to the Jina project. Yeah, now maybe I can try first. I can try Jina 101 first.
We've also got the My First Jina app tutorial, which is, I would say, Jina 101. It talks more about the building blocks and concepts behind Jina. Whereas My First Jina app, it walks you through building a simple first app. There's almost no code involved even, so it doesn't matter if you know much Python or not.
Yeah, I was wondering if I want to build some picture search engine, I would like to search some topics, for example, some food. When I have some picture of a food, and I would like to get related results. If I want to build such application, how much effort would I need to build it with Jina? Maybe some simple coding, and I just need to collect my training sets or collect my library, and I can easily build the application with Jina.
Yes, for that, I would recommend you to look at the Pokemon, this Pokédex search, Pokédex. So this here, we basically show an example that using Google Big Transfer model. So this is basically a pre-trained computer vision model released by Google. So you don't have to train the data or collect the training data by yourself. So this kind of pre-trained general model that's usually capture all the kind of universal patterns from the pictures, from the image, from the objects, and it's usually trained on super big data set. It's basically, it's a kind of like a god-like model, which knows everything, but not so good, right? But anyway, so you can use kind of this kind of universal model as kind of the encoder and then use it in Jina, right? So this is actually the result. So this is the result for searching Pokemon. So this is a query right? And this is a top K result. I think this is somehow related to what you have in mind, right? So basically here, so you want to search for food picture, and these are all like the burgers, different kind of burgers, right? And so basically it's like that, right? And for that, it's actually pretty simple. So this is basically the code here, and then this is let's say the underlying network flow or the workflow, and this is the dashboard, the visualization of that. And once you set up everything, and then you can just run it inside the Docker, right? So this in total will just take putting everything together. This will probably take you 1 hour to do this, right? So it's very easy. So, but for the first, as a beginner, so to have this running, you probably will take 1 hour, half hour to 1 hour, and then you do the indexing and the searching, and it provides REST API. You can query the top K, this kind of thing. So it's relatively, it's very easy.
Yeah, it looks so easy, and maybe I need a few hours to build such a project. Yeah, that looks great, and maybe I can try it later.
Yeah, definitely give it a shot.
Yeah,
nice. I've got a quick question for our community members. Which operating systems are you using? Is it Linux, Mac, Windows?
I usually use Mac.
I have 2 computers, and one is Mac and one is Linux.
Yeah, so basically these are the operating systems. Oh, you have Mac. Okay, good to know. Yeah. So basically this is so we are also working on the Windows support, but again, this is not trivial because the more that we go into low level, the more that we optimize Jina in low level, right? For example, we're using some socket, multiprocessing, event loop, this kind of thing. And the more that the Windows and the Mac and the Linux, their departure, right? They are different on the low level. So this is something, but still we still that put Windows support in our radar, and let's see, yeah.
Any other questions or comments or feedback or compliments or anything?
If there's no question, I would like to bring up a short discussion. Yeah. Can I share my screen?
Yeah, sure. Let me. Yes, go ahead.
Okay. Will I assign my laptop to do that? I think you just allow the smartphone. There's another device without microphone.
Okay, but then you have to use your smartphone to assign this to your laptop.
Okay, yeah. Gotcha.
But we have to look at the other options. I think we can set up this in the Zoom, so to allow multiple hosts. Usually we don't have to switch.
I think I had set this up today, so you should be allowed to add co-hosts. So I think I picked the option today.
Yeah. So today I'm really thinking about the how to select the index, select which index to query. And so this is a simplified version for the overall flow, the index. So we will have 2 pathways for the flow, and one each one will have one indexer. So the currently the left hand side, the indexer will index all the document with the label equal to label 1, and the right hand side will index all the document with label equal to label 2. So this can be done with the filter QL. And this is basically what we have done with the fashion MNIST example. During the query time, currently in the fashion MNIST example, we are actually add filter QL for each indexer, so that each indexer will only process the request that meet the condition. For example, here we say we build a document and we set the document to be to have the label equal to label 1. Then only the left-hand side indexer will process this request, will process this document, because here we have already set, say, this indexer only accepts the label that equal to label 1. So this is one solution. And the downside of this implementation is that we have to set up the tags for each document every time. And another solution would be using the query side we have for the Flow API. To use the query side, we what I saw is like I will add a filter QL at the end of the whole flow, and then I can set up the query side without touching the document. I can simply set the query side, say I want to select only the label equal to label 1 as a fact. Then this implementation can also select all the documents that has label 1.
So basically, it's you search for every index, but later you filter them out, right?
Yeah. So I'm wondering which one is a better practice.
So what was the first one? What was the solution 1?
Solution 1 will actually only do query on one of the indexers.
But how can you redirect the query to only to one index?
Because they actually, here I have marked the tricky part with a red box. They actually, for each indexer, we set, say, I only process the queries that have label equal to label 1.
You only process the query, or you only process the docs, right? Because this is doc tags data.
Yeah. Yes.
So the index are still called, but just with an empty list of documents, and that's so you get an empty list back, so the join doesn't join anything.
How about I think that both of the solutions are not elegant, and unfortunately,
so
I don't think there is an elegant way to do this right now. What I can think of is probably we add a tag, or we add tags directly at the request level, so that the pod or the driver, they can basically tell the information in the tags and decide whether to process or to just pass it through.
But this can be bad when you have you search with a PDF for other PDFs. You might want to go with the pictures of the PDF to one indexer and with the text of the PDF to the other. So you can't define this on request level, but only really on chunk level, which indexer to take. And this even decides the crafters beforehand will decide which one to take before they decide, oh, this is text or this is image.
But now what Nan suggests is that we already know the indexer. This indexer is about this particular information, and that index is about that particular information. And the question is, how can we route, or how can we route the request to the correct part, right?
Yes.
One question. The problem of solution 1 is that it does not dynamically set.
Yes. So basically, you have to set up the tags for each document, right?
Yeah, but it is flexible, right? I mean, the good point is in every batch or in every request, you might have different types of documents, as Max says. And you can, I think it's the more flexible. And the second option, the point is that you are overloading the indexer for searches that you might drop. So for me, solution 2 is not that good.
Fair point.
Yes, yes. I mean, but what do you think about the smart routing part? Adding a tag to the request so that the later part can decide whether to proceed or just pass it through.
I think, like Max, that it's not flexible to have multiple documents of different types in the same request.
Yes, but I was thinking like on the more general level, not necessarily related to doc. It's just the routing.
Then you force different documents to belong to different requests, which might not be optimal in terms of client side, from client side or bandwidth or communication perspective.
Especially if these documents fall out of a crafter, you don't even have this fine-grained control. So you can't even create multiple requests falling out of a crafter.
No, so let's just let's just make an example, which is not really let's say not probably not very accurate. But let's say we have two types of requests. We have two flows. We have two subflows, right? One subflow is running on CPU. The other subflow is running on GPU, right? I mean, the underlying components and all the algorithms are the same, but the only difference is that they are running on different architecture, right? And then we somehow mark the incoming request into CPU version or the GPU version, and then we send to different subflows, right? And you can imagine this can be useful. Let's say, in the future we monetize, and then we have the premium member which use GPU version, and the standard free member that use CPU version, right? So this is one way to redirect the incoming request to different subflows.
Okay, fair enough. But this is a different, this is one aspect of the problem, I think. So you're absolutely right. This it makes sense to also have this whole thing on a request level, or it may make sense. But I also think we need it on a document level. I think we can't. So there must be the possibility to go to a certain indexer somewhere on a document level.
So you're saying you won't have some kind of, it's not only filter, but actually to split the message into.
Yes. So think about the following. I have a patient somehow I have a medical app, and this medical app somehow you have a lot of patient data from different patients. And sometimes you have x-rays, and sometimes you have just this text description, and you index both. And now you have a patient which has certain symptoms. You have an x-ray, and now you want to search for similar patients in order to somehow get an idea, okay, how do they, what might be their problem. And then you want to somehow, you can't put x-rays and text in the same index, or perhaps you can, but let's say you can't. So you need an index for probably each of these things. Then you somehow in all of these indexes, you get similar results back. And then at the end, you need to merge them again. But you won't send all of the bits and pieces that you somehow with your crafter would chunk out of the patient information that you put into the system. You won't send each of the piece to each indexer, but just the one that somehow relates to a certain indexer. And there, I think you need to do this on a document level, because the documents are apparently chunks of the original request and not the whole documents in the request.
Yeah, so the current way of doing that is we basically broadcast, we publish the same request to all the consequent parts, right? But then on those parts, the first driver is a filter query language, right? So basically, all the parts receives everything, receive all the same thing, right? But then the first driver is different, is set differently. So this part uses this filter QL set to that tag, and that part set to different tag. So that the executor, what executor really working on is different. But from the P level, from the part level, they actually are the same. They receive the same request, just like the driver doesn't tell the executor.
Yes, exactly.
Okay, back to Nan's question. What is the best? What is a better solution right now?
So from this example, I think it doesn't make sense to first look up things and afterwards filter them out, but it makes sense to really have this filter QL beforehand to even don't look it up. Especially if somehow you set this text already in your flow as a crafter. So there I think it makes much more sense to do it beforehand. If you set this information outside somehow as part of the request, there I'm not so sure anymore. But I'm pretty sure that if you somehow set this whole thing already in a crafter, then it's in the hand of the person who designs the flow, and he can already says, okay, please don't even go into this index because my crafter already knows this is not the right thing to look there.
Yeah. Okay. Good. Yeah. So now is that all? That's all.
Yeah, that's all.
Okay. So I think then basically we're about time, right? So yes. Okay. So Alex, do you have anything to add on the DevRel side?
So from the DevRel side, we are now working with Analytica, a large influencer marketing operation to broaden our reach among KOLs and get out the good word about Jina. We have also really been diving into our metrics. I've been writing Python scripts using the GitHub API to scrape all the historical data I can. We can track the timestamp of every star we've got, information about who's giving us stars. We've been tracking forks. We've been tracking PRs. We've been tracking closed and open issues, baby. We're tracking the lot, except for commits, because yeah, we're going way over the GitHub API limit with that. Yeah, Hacktoberfest is going quite well. We've got some commits already, some of them admittedly spam, but that's to be expected with Oktoberfest. But we did get some doc corrections in Russian. So if anyone here speaks Russian, speak now or forever hold your peace. We've also got a couple of events coming up. I'll be speaking at the hashtag Everyone Can Contribute event with Rituja and Pratik on tomorrow. And Max is speaking at the NLP Zurich event, I believe on the 20th. So both of those we're really looking forward to. They'll be more technical than other presentations I've given. So yeah, what else?
So this everyone can contribute. This one is organized by GitLab, right?
It's organized by the guy in charge of it is one of the developer relations guys at GitLab. I don't think it's an official GitLab operation.
Okay.
But yeah. If anyone internally at Jina wants to see the stats that I've been gathering, I've got CSV, I've got JSON. I'm working with David to create a static site that'll present everything really beautifully. So we can get all of the information on one page instead of having to muck around. And as well as that, I've created counters. So we can see how many stars we get in a week, in a month, in the year, in all time. And we can do that for forks. We can do that for everything. If anyone has experience with the GitHub API or Twitter or Slack or LinkedIn or anything that we'd be interested in tracking, ping me and let's talk.
All right, cool.
Oh, and hey, community members. in the chat below or to the side or wherever your chat is. Join the Slack. We want to see you.
Yes. All right, cool. Well, I think this is a pretty fruitful engineering all hands, and this is exactly the form that we are expecting. So I think this week is probably very short notice. I forgot to send out the kind of the advertisement beforehand. Okay, but it's still very good that we have those community members joining. It's always very, very glad to work with community together, because this is how open source works. Right. Okay, so very nice, and thanks for your time, everybody, and let's call it a day. Yeah.
Thanks, Alok. Thanks, Bithia. Thanks, Xiao Lu, and thank you to the strong but silent type, Hai Luong. Thanks, everyone.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye.